Hello everybody, welcome back to youcramweteach. Today's going to be a solo video, and we're going to be discussing different types of rocks, igneous, sedimentary, and metamorphic, as well as the rock cycle. So let's get into it right after intro.
One day before a test or quiz, we got you. You'll be a satyr, fighting, braving the elements, Mendeley, genetics, Sokoto, feel of the power. You'll be a procrastinator, set into the last minute. All you gotta do is cram, pulling an all-nighter just to give it your best shot. Youcram will teach, youcram will do the rest.
Igneous rocks, derived from the Latin word fire, just like me, are formed when molten hot materials such as lava or magma cool down and condense. Igneous rocks can also be made of a couple different types of ways. When they're formed inside the earth, they're often called intrusive or plutonic igneous rocks. But if they're formed outside or extrusively, they're called extrusive rocks or volcanic rocks. Seems to make sense. If they're formed inside the Earth's crust, they're called intrusive. If they're formed on top of it, then they're called extrusive. So granite and diorite are common examples of intrusive rocks, and these are generally defined as having very coarse textures, very coarse, but they also have very large crystals or very large grains inside. And this is mainly because of the fact that when they were back inside the Earth, they were cooling for a very long period of time, and that enabled all of these crystals to form. Meanwhile, on the other hand, extrusive rocks like basalt and obsidian have extremely small grains and are really fine, really smooth, unlike their counterparts, the intrusives, which are really coarse, rough, and often cools more quickly. It cools really fast outside, and it doesn't allow crystals to form. They're really quiet and they're more smaller. And that's the main reason why. It depends on how they were cooled. And so extrusive rocks also have different types. They can sometimes be called vesicular, or they have a holy texture in them, and that's just because when magma cools, there's magma pockets inside. And when those magma pockets form, and we have an example of one of these right here, it's going to be pumice, and, well, that's a very common example at least. And inside of these little holes, what forms is mainly going to be the fact that and when these are trapped, they give a bubbly texture, and that's mainly what vesicular means. Now let's move on to sedimentary rocks. And these are formed from, as given in the name, pieces of existing rock and or organic material, mainly. And these are often classified as sediments. It's in the name. Hooray! And there are going to be three different types, or three main different types of sedimentary rock. We have classic sedimentary rock, organic/biological sedimentary rock, and we have chemical sedimentary rock. Now I'm going to be discussing classic and organic sedimentary rock first, because the formation of both of those is quite similar. So classic sedimentary rock, like sandstone over here, is going to be formed from clasts, or pieces of other rock. That's what clastic means. It's kind of in the name. Yeah. And then organic sedimentary rock, like coal over here, they're going to be formed from biological materials like plants and bones and stuff that's organic. Like in the name, it's pretty self-explanatory. And then the formation of both of these types of rocks begins with weathering and erosion. So first, it weathers off old pieces of rock, or exposed pieces of rock, and then by erosion, they're moved to a new location. And those sediments that have been moved, the sediments that have been weathered from pre-existing rock and moved by erosion, they start settling down, and when those start settling down, they become compacted. And when they become compacted, they form rock. That's how rock forms. So yay, we're geniuses. And now let's move on to chemical sedimentary rock. An example of this would be limestone, halite, and flint in front of me. And these form from chemical precipitation. And basically, chemical precipitate or chemical precipitation is formed from a chemical compound like silica or salt, and that's how chemical sedimentary rock is going to be formed. There's not really too many examples of chemical sedimentary rock, but it's a fascinating concept nonetheless. Now time for my
favorite rocks, metamorphic rocks, and these are rocks that have been changed from what they used to be by immense heat or pressure. Now, sometimes I think of high school and middle school as the formation of metamorphic rocks. Before, we were igneous rocks or sedimentary rocks, and now we all become metamorphic rock because of the pressure
of high school and middle school. You know, that's a good way to remember it. That's how I personally remember it. And these types of metamorphic rock, there's two main types. You have foliated metamorphic rocks, and you have non-foliated metamorphic rock. And here is an example of foliated rock, and here is an example of non-foliated rock. And so, what is foliation? So you can see quite clearly in this rock right here that there's many distinct layers, and there's many distinct formations of layers. And you can clearly tell apart from one layer from another. That's what distinct means. And from here, you can see that it's all kind of jumbled up together. And that's basically what foliation is. If you have these nice looking layers, that's foliation. But if you don't, then that's not foliated, and that's why it's called non-foliated rocks. And, you know, kind of simple, you know? Yay! This is all kind of simple. So, an example of foliated rock is going to be granite. And granite, when it goes under great pressure, it forms gneiss, which is going to be a type of foliated metamorphic rock. Gneiss. You know, it's spelled G-N-I-E-S-S, but you're supposed to pronounce it nice, like you're being nice to someone. Like, I never understand that. Come on, English language, why? And then non-foliated rocks are formed the same way, but they don't contain minerals that are going to be lined up in such a way. And as I stated before, that's the main difference between them. And an example of this would be limestone, which is going to be right above this one, and it can turn into marble. And non-foliated rocks can also form by metamorphism, and that's basically when magma comes into contact with other surrounding rock near it. And that's basically how metamorphic rocks are formed. Now for the rock cycle, my favorite cycle in all of science. It really isn't. I think that would probably go off to the carbon cycle. It's a pretty interesting cycle, but I mean, this is also an interesting cycle if you like rocks and you want to contribute your entire life to studying rocks. I mean, it's pretty amazing. So we have the rock cycle over here. So at the top, we have magma. And then that magma, the lava, it crystallizes. And then it forms igneous rock. And that igneous rock, it has one of three ways it could go. It could either melt and form magma. It could go under immense heat and pressure, just like high school. It could form metamorphic rock. Or weathering, erosion, deposition could occur. And that's when that rock is going to be weathered away. Little bits of that rock are going to fly off. Then erosion is going to be when those bits of rock are carried away, and then deposition is when it's going to deposit into the ground and it's become sediment. And then when it becomes sediment, it can compact and cement, and then it can form sedimentary rock. And then here at sedimentary rock, we have one of three things that could occur once more. It could melt, and it could form magma. It could have heat and pressure occur to it and become metamorphic rock, or it could have weathering, erosion, and deposition occur to it, and then it could become sediment once more. Now let's move on to metamorphic rock. So, at metamorphic rock, there's only really one thing that can happen once you're past metamorphic rock. You can melt into magma, and then magma is where the cycle all begins. Isn't that fun? So that's pretty much the rock cycle, and that's the basics of it. Alright, so that was the rock cycle. I hope you all had fun learning about it. I hope to see you again very soon on youcramweteach. Until then, I hope you have a fantabulous 24 hours. It's sandstone only. I made a mistake. So processes,